Right, so the first question, who remembers what superposition means? Yeah, what's that here, right? Yeah, in a special kind of way. So superposition, you can take that back, thank you. Write this down. But does someone want to try and say out the definition without looking? 5a. Superposition of two waves is when two waves combine to form a new wave. And what's the key thing here?
Combine and two waves combine.
Very good. They combine algebraically.
Yeah.
So the combination is the algebraic sum of the two waves. Algebraic sum of the two waves. Okay, so this is 2 marks. Would I get 2 marks? Let me see the marking scheme. When two waves cross, the total displacement is the vector sum or algebraic sum of the individual displacements due to each wave at each point. Yeah, okay. Well, I have the key thing to hit on there is the algebraic sum. That would be 1 mark, you know. And the fact that superposition means two waves coming together, so combine. They would be the key words there. Okay, let's have a look at B now. What do you need for complete destruction? So what do you need for the two waves to cancel? Yeah, well, let's try and get a bit technical. So what do we need? Yeah, same frequency. There's a special word for that. For same frequency. No? Coherence. And what else do we need? Same amplitude. Yeah. But there's one other thing as well, which is what Tal you were getting to. No, so let's try not to say opposite. Let's just try to get a bit more technical. We need to say that the crest matches the trough of another wave. So we say that the crest of one. What verb could we use here to say happens at the same time? Occurs or coincides. Oh, let's just say happens. Crest of one matches.
Or combine. Can I use combine?
Or combines, yes, yeah. The trough of the other. Now, if you don't want to write all of that, which why would you? There is a term that means this, which I haven't taught you yet, but there's a special term that means exactly that. Does anyone know it? I'll tell you it now. Out of phase means exactly that sentence. So if you don't want to write that whole sentence, and you, Tal, were saying opposite, if you're looking for something short that means that, you say the waves are out of phase. Or you should really say completely out of phase. Completely out of phase would do. Fully out of phase. Okay, let me check the marking scheme. The waves need to be exactly out of phase with each other and have the same amplitude. Okay, so I got that. Alright, let's look at the next one. In practice, the two light waves will have come from a single source of light. Why is this necessary?
So that the frequency remains the same.
Coherent. Yes. Same frequency. Which is kind of what I was mentioning here in the last part, wasn't it? So I'll just say for part 2, this will ensure the waves are, what's the word? Coherent. Now, how many marks so far? It's been 2, 2, 2. So we have 6 marks so far. Not too bad, I don't think. And that's A and B done, so now we're on to C part. Okay. Can I go back to the question now? Have you written that down? So C part. We now have Young's double slit experiment. Here is the frequency. And the screen is 1.55. And the distance, it's 20 fringes, 80.5. Now, this is actually good because that's what we were just doing in the book. So if I look here at the marking scheme, if I hold on, you don't want to see the answer?
No.
Okay, you want to try it yourself for a minute? So just work ahead of me. What we're looking for here is the S. So use the second formula. Let's see what they do.
So here to find the x we need to divide 80.5.
So what are the,
by
can you,
20? Yes?
Hold on, one at a time. So what are you asking me?
To find the x we need to divide 80.5 by 20, right?
Looks like it, because this will give us the, yes, the x, yeah. Well, wait, well, this is what do you get when you divide by 20?
4.025.
And if you look here, what do they have for the x? Where is it? 4 point, where is the
80.05, 80.5 times 10.
that's the x, is it? Is that what you got? What did you get?
Isn't it the same what you want?
You just said it a moment ago, divide by 20.
80.5 divided by 20.
Yeah, what?
0.5 is what we're given.
Yes.
The distance for 20 of them.
They have 20 here. Let's do it now.
Yes, please.
Okay. So, do you have the information down so you can read it? Oh, actually, I have it here. Okay. Part C. The frequency is 4.77 times 10 to the 14. Now, a moment ago, Tanish, we were talking about, if there's 20 fringes, then we should divide by 19. But in the answers, I see that they divide by 20. So now I don't know anymore. And so I'll divide by 20, which is what I was originally doing. But I'll have to double check that to see is it 19 or 20.
They say 20 fringe spacing.
Oh, they said, no, is that different to the question in the book? They didn't say the word spacing.
Yes.
We have the answer. So in this question it said 20 fringe spacing. So spacing being the noun for each piece.
Oh.
Whereas in the book I think they said 20
the whole thing
fringe.
is like, yeah.
Yeah, they said 20 fringe dots or something. Yeah. So it is 20 here, not 19.
With a spacing of 5 inches.
Oh, I know you just ruined it for all of us. Alright, well now I don't know anymore. I'm back to not knowing. So we'll divide by 20. Okay. So that's the F. Okay, and the D here is 1.55 and the X is 80.5 times 10 to the minus 3 all over 20. What's that, please?
1.025 times 10 to minus 3.
Okay. And we want the S. So the do we know the lambda? No, we don't, but we can get the lambda because we can use this formula. V equals F lambda. Therefore, what does lambda equal?
V
V over F. Now, do we know the V? We do, because what does it say in the question? It's light. So we do know it. So it's 3 times 10 to the 8 over 4.77 times 10 to the 14.
So the first question is lambda.
Well, no, actually, interesting. You would think that they would ask you for the lambda first, so you could do the question, but they don't. We need to get the lambda first.
So what did they ask for?
We're still getting to it. They want the S.
Oh.
So what do we get here, please?
6.289.
6.289.
Times 10 power minus 7.
Okay, and that is, so the lambda. Right, now, let's see what we get. So we know that lambda equals, what is it, x d, xs over d. So s equals lambda d over x. So that is 6.289 times 10 to the minus 7 times, what was the d? 1.55 over x. 4.025. Okay, what do you get, please?
It's 2.3 times 10 power minus 4.
Are we all sure?
2.42 times 10 to the minus 4.
2.42
42.
times 10 to the minus
4.
4 meters. So if I give this, if you divide this by 10 to the minus 3 to make it milli, then we'll get, what's it, 0.242 millimeter. I don't think we even need to do that, but let's see what we have. Yeah. All right, 3 marks. Okay, back to the question now. Now the next part, now look at that, 3 marks, that's not so bad, is it? Although we did have to work a little bit for it. If the distance between the double slits and the screen is reduced to 1.25, determine the spacing between the adjacent dark fringes.
Also the D is reduced.
So yes, now the big is reduced to 1.25. Right, now before I even do it, just look at the formula. If this is now half of what it was before, isn't this at a 1.25? Oh, sorry, it wasn't. It was 1.5 originally, wasn't it? So 1.25 over 1.5, 5/6, isn't it?
It was different.
Yeah, if it was a half, it'd be nicer. Anyways, if this gets smaller, then this will get smaller too, and the x will. What are we looking? No, sorry, the x will change. Let me rewrite this
What
here.
is the question? Can you show it first?
Yes, they want the new x basically for the changed distance. The x equals lambda d over s. The lambda is the same, the s is the same, but now this is reduced to 1.25. Okay, so here, let me do it here. See part 2. You want the x now, and it's using the same formula, lambda d over s. But the difference now is the d is 1.25. So it's 1.25. I don't have the numbers, but can you type the numbers in? The only thing that's different is this is 1.25, but the lambda and the s is the same. So what do we get here, please?
3.25.
3.25 times
10 to the minus 3.
10 to the minus 3 meters. Now let's just draw what that looks like. So we have a really bright dot here, and then we have less bright dots here, and then we have them here, and then here is dark, So dark, bright, dark, bright, dark, bright, dark, bright, and so on. And what they would like to know, determine the spacing between the dark fringes. Did we get this?
Yes.
Yeah. Now, they tried to confuse you a little bit, but if you think about it, the distance between the bright fringes is the same as the distance between the dark fringes. So, it was just a way to try and complicate the question a little bit, because it's already
dark
pretty easy.
dots are the same size as bright dots.
That's what we...
But can you come?
I know I didn't draw it like that, but that's what... Yeah.
Can you come clear with the point? If it gives the full distance, do I have to divide by whole number of fringes or minus 1? Like if there's 20 fringes, divide by 20 or 19.
I'll just tell you what we need to do for the exam. Divide by 20. But this makes me sad on the inside.
Because I still remember during high school we divide minus 1. Like
Yeah, well, it's very possible. I'll have to check it out in another book, okay? I know what you're saying. I'm just telling you, in the marking scheme they divided by 20. And at the end of the day, you want to match up with the person who's correcting it, the marking scheme. So divided by 20. But I will confirm this for you for the next class, okay? You shouldn't be happy, because I'm not. Alright, but it's divided by 20. I'm not saying that's right. I'm just saying that's what they did. Okay, can we go to the next part? So the next part, if the light, the monochromatic light, is replaced by white light, what will happen to the dots? Now this one's a little bit tricky, but I'll explain it here now down below here. But how much battery do I have? Just about. So what's happened now is instead of having red light, they have white light. And I'm sure you know this from middle school, but white light is actually made up of all the colours. And how do you separate the colours? With a prism. So you have in here the red, the green, and the blue. True? Now, you remember our formula, n lambda equals s sine theta. So we have n lambda over s equals sine theta. Now, what's our formula for lambda if we want to change it in the frequency? We know that c equals f lambda. So if I put that into the formula, I get n lambda c over f, isn't it? Over s equals sine theta. Now, which of my three colours has the biggest frequency? The red, the green, just in my little picture, the red, the green, and the blue. The blue. As the frequency gets bigger, what happens to this number? It gets smaller. So what happens to this number? Smaller. So what happens to this? Smaller. So what happens to this? Smaller. So in other words, for big frequency we have a small angle, and then for a small frequency we have a big angle. So result is the red light will be pushed up higher than the blue light. So when you look at the dot, it will be red up here, then green, red, sorry, no, well in my example, red, green, and then blue. So the dots won't be red, they'll be multicoloured, and the ones with the smallest frequency get pushed out the most. So the question now is, if the light was replaced by white, what will happen to the fringes? Well, I just explained it there. So if we look, fringes either side of the centre will be bluish near to the centre and red on the side furthest away from the centre. Red on the side furthest away from the center. And they're calling this here the center. Huh? You're bluish, don't worry about that. Is that okay? Yep. Right, so how many marks have we clocked up now? 6, 9,
15.
wow, 14. So we have part D for the remaining 6 marks, which we can do very quickly as well.
No, we have no time.
No.
You don't have to you don't have to pass it. Just give it to us as a homework.
No. It'd be nice to have this question finished now. Oh, rats! I left my charger in the teacher's room.
Homework.
Shh. Super quick. So I'll do D. What they say in D is there's a speaker on one side of the room and a speaker on the other side of the room, and as you walk from one side to the other, the sound goes up, down, up, down, up, down. What's happened here, explain why this has happened. What's happened is a standing wave has been made between the 2 speakers. Now let me draw it a bit better. So the reason for the increase and the decrease is because you're actually walking through a standing wave. 2 marks. Right? So the reason is because it's a standing wave. Okay. Part 2. Another 2 marks. If the distance between the loudest points is 0.85 meters, what's the wavelength? Where does the loudest sound happen, do you think? At the antinode or the node? Antinode. So they're saying the distance between the antinodes is 0.85 meters. Yeah. So what would the wavelength be? 2 times 0.85, which is 1.7 meters. Yes? Yeah, the distance. This is right.
Yes.
Let's check. Yeah, actually, isn't this what we were saying with, this was Ali and maths as well, yeah, if you just double the number. Yeah, so it's fine, isn't it? And anyways, if we look at the marking scheme,
Yeah, 1.7.
1.7.
Yeah.
So the last part is, what's the velocity? So what's the formula for velocity? Do we know the lambda?
Do we? Yes, it is.
Yes, and do we know the F?
Do we? Do we know F?
It doesn't say in the question, does it? Oh no, it does.
Yeah.
200 hertz.
200 times 1.7.
200 times 1.7, what's that?
340.
340 meters per second. And battery's about to go and finish.